Hi everybody. Today let us see the rearrangement reaction of Pinacol-pinacolone rearrangement. First let us understand what is Pinacol and Pinacolone. Look at this overall equation of Pinacol-pinacolone rearrangement. Here the starting material is called Pinacol because these are all the class of compounds which have two hydroxy group adjacent to the two carbon atoms, that is 1,2 hydroxy compounds, which is converted into its corresponding keto compound in presence of mineral acidic conditions. Okay, this kind of rearrangement process is called Pinacol-pinacolone rearrangement. Here we can observe the starting material. Here the methyl group from the second carbon atom is migrated from its position to the adjacent position carbon. Here we could see that in the product side. So now let us go to the mechanism. In the first step, what is the role of H plus, that is mineral acid? It will donate the H plus ion to the reaction medium. So that H plus was protonated to any one of this OH group because the acidic condition should be maintained in taken only 1 mole of acidic condition. So the first OH group is protonated so as it results in the formation of an oxonium ion. The formed oxonium ion is again relieved in the form of water so as it generated a tertiary carbocation. It generated a tertiary carbocation in that position of the OH group which was present already. So next, it is in the form of cationic nature, so it has to be stabilized to a stable product. So there, what is happening? The second OH group is play a vital role and it loses one H plus ion, and then the bond is migrated towards the carbon atom. Simultaneously, the methyl group from the first position to the second position is migrated so as via 1,2 shift. So that what is happening? We are getting the product, that is Pinacol by the loss of one H plus ion. So now I conclude the overall rearrangement. Our starting material is Pinacol under the reagent conditions of mineral acid. It gives a product of Pinacolone. And the points to be noted is, in the first step, generation of a carbocation. Second step is the migration of the methyl group from the first position to the second position. Finally, loss of water gives you the Pinacol product. Hi everybody. Now let me see the second example for the same Pinacol-pinacolone rearrangement with some specification of the formation of a stable carbocation. Now you look at this starting material. Here also we have a typical 1,2 dihydroxy Pinacol molecule, but this one is unsymmetrical because the first carbon contains 2 phenyl group and the second carbon contains 2 methyl group. So as here also the same reagent condition is maintained and it gives the product only on the migration of methyl group, not the migration of phenyl group. Why? Here is the carbocation selectivity plays a vital role. Now let me see the mechanism. First, as usual in the first case we have seen here, the first step is the protonation of the OH group. Here the selectivity is more important. Among the two OH group, which OH group should be protonated? If you protonate the first OH group, so you will get the carbocation here. So as it is substituted with 2 phenyl rings. If you protonate the second OH group, here also you will get the tertiary carbocation, but the carbon is substituted with 2 methyl groups. And we'll compare these two different carbocations. The phenyl group substituted carbon containing a carbocation is more stable than the second one because once After the protonation, the oxonium ion is generated and the oxonium ion is relieved in the form of water, so as it results in the formation of a tertiary carbocation on the two phenyl group substituted carbon. Once if the two phenyl group substituted carbon containing carbocation, that is more stable because it is also stabilized by resonance with the two phenyl groups. So the possibility of the carbocation stabilization through resonance is occurred here. If the same carbocation is formed in the second carbon, that is substituted with the two methyl group, here it is not possible to stabilize the carbocation by resonance by the methyl group. It can only induce the inductive effect, not the resonance impact. That is why here the only product which will be formed by the formation of carbocation on the two phenyl group substituted carbon. Then automatically in the second step, loss of one H+ ion from the second OH group, so as the migration of the methyl group from the second carbon to the first carbon is occurred, and which results in the formation of the expected pinacolone product.